When we approach the sort of modern landscape of disciplines in academic spaces, we tend to think, isn't this the natural way for things to be? But in fact, they are of relatively recent invention in that most of the architecture that we experience, say, in a modern university context, arose in the 19th century.
Breaking the Boundaries, the Case for Interdisciplinary Science, with Alan Love.
For most of organized human history, when people were interested in questions, they studied them, but did not necessarily have sharp boundaries about who was allowed to study them or whether you could ask only one kind of question rather than another about, say, the planets or medicine or the behavior of light or something like that. So what happens in the 18th and 19th century in particular is that the community of investigators grows in size. For most of history, the people involved was just a very small number. And as the community gets larger, we need some form of organization. And that form of organization starts to fall out along lines of interest that people have in different kinds of phenomena. So the chemists that we think about are interested in chemistry, and we see chemistry emerge as a space, or physics as a space, and different areas of physics, so the study of optics or the study of planetary motion. And into the 20th century, that structure starts to also solidify for the humanities and social sciences. And philosophy isn't a discipline until the late 19th, early 20th century. The origin of the American Philosophical Association is actually 1895. So this structure is very good for making it possible for large groups of people to be coordinated in spaces to do this kind of research, to have conferences where they can meet up and talk to one another about the progress that they've made, for them to have journals that they can publish their research in and make sure that other people know what they're doing. However, over time, that leads to people being relatively separated from one another and not spending as much time talking what might be thought of as more broadly across boundaries or in ways where we might see creative combinations emerge. And thus, it's perhaps not surprising that, especially in biology, there is deep interest in cross-disciplinary work because the organism exhibits multiple disciplines in its very architecture, whether it's the physics of the embryo or it's the physiology of the temperature regulation in the body, or whether it's the movement of cells in the circulation of the bloodstream. Organisms on their own, in their spatial and temporal scales, cover multiple disciplines. So when we come to think about how best to prosecute research in biology, although it's certainly been productive that it was organized along disciplinary lines, certain kinds of questions that involve crossing those lines tend not to get asked. And therefore, my initiative in trying to organize work, especially in the space surrounding teleology, is to find ways to let those boundaries be relaxed and let people be able to range more widely and interact more broadly so that they might build new collaborations with people around problems that no longer can be confined to those disciplinary spaces. most of the individuals working in what we would now call science, they would have called natural philosophy, um, definitely moved easily across boundaries. Isaac Newton worked on everything from optics and chemistry to some of the standard physics that we think about, as well as thinking about how they apply to living systems. Individuals like Darwin also had that capacity. He actively consumed in his reading economic literature, literature from culture and anthropology and aesthetics to develop his own thinking. So these individuals, I think, had a much wider range that they took in when they were developing their own thought and saw themselves as working on a wider range of problems maybe than a contemporary scientist might. However, at the same time, we have to recognize that those individuals in the past had a certain freedom to do what they did because of their privilege, right? Because they were independently wealthy, because they had an established position within a university network or a place that gave them the resources to do those things. And so one of the important transformations of the 19th and 20th century is that science is now something that can be pursued by a much wider range of people than was possible beforehand. That you can do science as a career. You can make a living. You don't have to come from independent wealth in order to pursue these questions. However, it still takes money to do science. You still need grants. You still need to be able to run your experiments and do your field work. And so it's absolutely critical that we think actively about how the science is funded, and especially science that falls outside of some of the standard funding mechanisms, which have been primarily organized around disciplinary structures that are more common. Thinking about how the landscape of science might change if we lost some of the rigidity of disciplinary structure is an exercise in imagination that probably could go in different directions for different people. One would be that teaching would change. We would no longer be taught a kind of introductory sequence within a discipline, but rather would have ways in which co-teaching arrangements were more common and students were exposed to a wider range of material together rather than kind of packaged separately. So ultimately, I would expect that a transformed landscape of science and philosophical inquiry is going to be one in which teaching and research look very different than they do today.